Welcome back to the Deep Dive. We're here with your focused analysis of current affairs aimed squarely at your UPSC preparation.
That's right.
This is our session for April 19th, 2025, Part 2.
And as always, we'll be digging into some key developments.
Yes, and remember, some of these topics might ring a bell. We might have touched on them before. Think of it as revision, building that solid understanding. Others will be fresh.
Absolutely. It's all about connecting the dots for that comprehensive view you need.
Okay, so what's on the table today? We're starting with some pretty mind-blowing stuff from exoplanet research. Potential habitable worlds.
Definitely exciting. Then we'll shift to some well-deserved recognition for Indian scientists in high-energy physics, a big prize.
Excellent. After that, we tackled the global water crisis, looking at some new innovations there.
Very critical topic. Then we'll venture back out to space, exploring intermediate mass black holes. There's been an interesting Indian detection.
Fascinating. And sticking with conservation closer to home, India's growing role in protecting big cats.
Yes, some important agreements there.
And finally, we'll round things off with some quick but crucial updates on national policy, tech developments, and important observances.
So our mission, as always, is to pull out the key info from your source materials, make the links clear, and highlight why it matters for your UPSC prep.
Exactly. Ready to dive in. Where should we kick things off?
Let's start with that outward look. The exoplanet K2-18b. It's been making headlines again.
It has, hasn't it? So what's the latest? What exactly have they found this time?
Well, the really striking thing is the detection of two specific gases in its atmosphere, dimethyl sulfide, that's DMS, and also dimethyl disulfide, DMDS.
Okay, DMS and DMDS. Why are those particular gases so significant?
Because here on Earth, these gases are overwhelmingly produced by life, specifically marine phytoplankton, microscopic algae in the oceans.
Wow. So a direct potential pointer to biological processes as we know them, at least.
It's certainly a very suggestive finding from an astrobiology perspective. For UPSC, think about how this pushes the boundaries of searching for life, looking beyond just oxygen or water for these kinds of biosignatures.
And K2-18b, we have discussed it before, right? This isn't the first detection in its atmosphere.
Correct. Previous observations, also using the James Webb Space Telescope, the JWST, had already found methane and carbon dioxide. So we knew it had an atmosphere with some key molecules.
Right, context building. But DMS and DMDS feel different, more specific maybe. How strong are these signals?
That's another intriguing part. The concentrations detected are, well, remarkably high. We're talking thousands of times stronger than the typical background levels we see in Earth's atmosphere.
Thousands of times. That does sound significant. How on Earth or off Earth, I suppose, do they detect such specific gases so far away?
It's done using something called the transit method. Basically, when K2-18b passes in front of its star from our viewpoint,
It blocks a tiny bit of the star's light.
exactly, a tiny dip in brightness. The JWST is incredibly sensitive and analyzes how that starlight changes as it filters through the planet's atmosphere during the transit. Different gases absorb light at specific wavelengths, leaving a unique chemical fingerprint.
Like atmospheric fingerprinting from light years away. Amazing. And there's a specific classification for this type of planet, isn't there? Something about oceans.
Yes, K2-18b is classified as a Hyson exoplanet.
Hyson.
It means a potentially habitable planet that's thought to be covered by large oceans and has a hydrogen-rich atmosphere. It's a relatively new category in exoplanet studies.
Ocean-covered hydrogen atmosphere. Hyson. Makes sense. Now, these are faint signals from far away. How sure are scientists about this detection? Is it definite?
Well, in scientific terms, the detection has reached what's called a 3 sigma level of statistical significance.
3 sigma. What does that translate to in terms of certainty?
It means there's a very low probability, about 0.3%, that this detection is just random noise or an error in the measurement. So it gives scientists a high degree of confidence that the gases are really there. It's not absolute proof, but it's strong evidence.
Okay, 0.3% chance of being wrong. That's pretty confident.
Yeah.
Can you quickly remind us of the key stats for K2-18b size location?
Sure. It's a fair bit larger than Earth, about 8.6 times the mass and roughly 2.6 times the diameter. It orbits a cool dwarf star called K2-18.
And crucially,
It's in the habitable zone of that star, meaning the distance is right for liquid water to potentially exist on its surface.
the Goldilocks zone.
Kind of, yes. And it's located about 120 light years away from us over in the constellation Leo.
So, habitable zone, potential water, ocean world candidate, hydrogen atmosphere, and now potential biosignatures. It's building quite a case, isn't it?
It is certainly one of the most compelling targets right now in the search for life beyond Earth.
And all thanks to the James Webb Space Telescope. Just briefly, what's its main mission?
JWST is a major international collaboration. NASA, ESA, CSA, launched in 2021. Its goals are broad. Looking back at the early universe, studying how stars and planets form, and as we see here, analyzing exoplanet atmospheres for signs of habitability. It's really pushing the frontiers.
Truly revolutionary science. Okay, let's bring our focus back down to Earth, or perhaps just under the surface of reality. Let's talk about CERN and a big win for Indian science.
Yes, this is fantastic news. The Experimental High-Energy Physics Group from the Bose Institute in India has been awarded the 2025 Breakthrough Prize in Fundamental Physics.
The Breakthrough Prize, that's a major honor.
It absolutely is. They're being recognized as part of the wider ALICE collaboration at CERN. This kind of fundamental research, remember for UPSC, often seems abstract, but it underpins so much from new technologies to our basic understanding of the cosmos.
So the prize isn't just for the Bose Institute group alone.
No, the 2025 prize acknowledges the collective work of thousands of researchers from, I think, over 70 countries. They work on the 4 main experiments at CERN's Large Hadron Collider, the LHC.
Right, the LHC. And those 4 experiments are
ATLAs, CMS, ALICE, which the Bose Institute is part of, and LHCb.
Okay. And what specific achievements are being recognized with this prize? What breakthroughs are we talking about?
It covers several really fundamental areas. First, making incredibly precise measurements of the Higgs boson's properties. This helps confirm our understanding of how particles get their mass, the whole symmetry-breaking mechanism.
Cornerstone stuff for the standard model of particle physics. What else?
Also, the discovery of new types of strongly interacting particles, expanding the particle zoo, so to speak, plus studying very rare particle interactions and trying to understand why there's more matter than antimatter in the universe, a huge puzzle.
The matter-antimatter asymmetry, right?
Exactly. And overall, just pushing the boundaries of exploring nature at the very smallest scales and under the most extreme energy conditions, which is what the LHC allows them to do.
Incredible work. Can you briefly tell us what each of those 4 experiments, ATS, CMS, ALICE, LHCb, focuses on? What makes them different?
Sure. ATLAS is, well, physically the largest detector ever built for a particle collider. Huge. CMS is also a general-purpose detector, like ATLS. It studies the standard model, searches for the Higgs, but also looks for things beyond the standard model, like extra dimensions or particles that could be dark matter.
Okay, the big generalists. What about ALICE?
ALICE has a more specific focus. It studies something called quark-gluon plasma, or QGP.
Quark-gluon plasma.
It's this super hot, super dense state of matter that scientists believe existed just microseconds after the Big Bang. ALICE recreates tiny droplets of this early universe soup.
Wow, and LHCb?
LHCb specializes in studying the differences between matter and antimatter. It does this by looking very closely at particles containing a specific type of quark called the beauty quark, or B quark.
Beauty quarks, why them?
Because their decays can reveal subtle clues about why matter dominates over antimatter. The B quark itself is the second heaviest quark we know, with a negative 1/3 charge.
Fascinating distinctions. And CERN itself, the organization. Key facts.
CERN stands for the European Organization for Nuclear Research. Founded back in 1954, a real pioneer in post-war international science collaboration. Its main lab is on the Franco-Swiss border near Geneva.
And membership?
It has 23 full member states, mostly European. But importantly for us, India is an associate member state, contributing significantly to the research efforts.
Great to see India playing such a key role. All right, let's shift focus dramatically now from the infinitesimally small to a very large-scale problem. The global freshwater crisis.
Yes, a critical issue indeed. The statistics are quite sobering. You know, about 71% of the Earth is water, right?
Right, the blue planet.
But only about 3% of that is freshwater. And it gets worse. Only a tiny fraction of that, maybe around 0.06%, is actually easily accessible in rivers, lakes, and shallow groundwater. Most freshwater is locked up in glaciers, ice caps, or deep underground.
Just 0.06% readily available. That really puts the challenge into perspective. So what's new on the solutions front? Any innovations?
There are some promising developments. One that's caught attention is a new material based on graphene. It's hydrophobic water repelling.
Graphene, again, seems to pop up everywhere. How could a water-repelling material help with getting more fresh water?
It sounds counterintuitive, right? But this property could potentially make water desalination processes much more efficient. Think about membranes that selectively allow water through but repel the salts more effectively, perhaps requiring less pressure or energy. It's being touted as a potential game changer for desalination.
Interesting. Any other innovative approaches?
Yes, researchers at IIT Bombay have developed something they call lotus leaf-like solar evaporator.
Inspired by nature.
Exactly. They mimic the surface properties of lotus leaves to improve the efficiency of using solar energy to evaporate salt water and collect the freshwater condensate. Another angle on desalination.
Very clever. To appreciate these new ideas, maybe we should quickly recap the main ways we desalinate water currently, the established technologies.
Good idea. Broadly, they fall into two camps: thermal and membrane technologies.
Okay, thermal first.
Thermal methods basically involve heating salty water to create steam, pure water vapor, and then condensing that steam back into liquid freshwater. It leaves the salts behind. This is often used for seawater, which has high salinity.
Like boiling water on a stove and collecting the steam?
Pretty much that principle, yes.
Yeah.
Its advantage is it can handle very salty water and sometimes can be energy efficient if waste heat is available. But it can suffer from scaling mineral buildup and can be costly if you're using conventional fuels for heat. Examples include technologies like multi-stage flash distillation, or MSF, and multi-effect distillation, MED. India has some low-temperature thermal desalination, LTTD, plants too, like in Lakshadweep.
Okay, that's thermal. What about membrane technology?
Membrane tech uses, well, membranes very fine filters. Water is pushed under pressure through a semi-permeable membrane that allows water molecules to pass through but blocks the larger salt ions and other impurities.
Like a microscopic sieve.
A good analogy. This is more common for brackish water, which is less salty than seawater. It's often seen as more environmentally friendly. Some methods like electrodialysis don't need chemicals, and the plants can be smaller.
Downsides.
The main challenges are managing the leftover concentrated brine, which is very salty wastewater, and ensuring complete removal of all dissolved solids and microbes. The most common membrane method is reverse osmosis, or RO. The Nemali plant in Tamil Nadu uses RO, for instance.
Right, RO is familiar from home water purifiers too. So these new graphene and solar evaporator ideas could potentially improve the efficiency or cost of either thermal or membrane approaches, or perhaps offer new pathways.
That's the hope. Making desalination more accessible and sustainable is crucial for water security.
Absolutely. Okay, let's journey back out to the cosmos for our next topic. Intermediate mass black holes. An Indian telescope made a detection.
Yes, that's right. Scientists using the Devastal Optical Telescope DOT have detected and measured properties of one of these intermediate mass black holes, or IMBHs.
Devastal.
Yeah.
That's the big one in India, isn't it? Tell us about the telescope and the team.
Yes, DOT is India's largest optical telescope with a 3.6-meter mirror. It's located near Nainital and operated by the Aryabhata Research Institute of Observational Sciences, ARIES. ARIES is an autonomous institute under the Department of Science and Technology, so a significant Indian facility and research group behind this. It was commissioned back in 2016.
Great to see it making these kinds of finds. So what did they find? Where is this IMBH?
This particular IMBH is located about 4.3 million light-years away, in a relatively faint galaxy. What the ARIES team did was observe a cloud of gas orbiting around this unseen central object.
How did the gas cloud reveal the black hole?
By its motion. They measured the gas orbiting at a distance of about 2.25 billion kilometers. And crucially, they measured its velocity dispersion, basically, how spread out the speeds of the gas are within the cloud. It was very high, around 545 kilometers per second. That high dispersion implies a very strong gravitational pull from a compact, massive object in the center of the IMBH.
545 kilometers per second. Incredible speed. You called these intermediate mass. Why is finding them significant? Have they been hard to spot?
Extremely hard. IMBHs are thought to be the missing link between the smaller stellar mass black holes formed from collapsing stars and the supermassive black holes found at the centers of most large galaxies.
Why missing? Why so elusive?
Well, they tend to be in smaller galaxies, and they don't typically accrete matter as dramatically as supermassive black holes, so they don't shine as brightly from accretion disks. They're harder to see. Finding and studying them helps us understand how black holes grow, potentially how supermassive ones form. Maybe they grow from IMBHs merging.
So they fill a gap in the evolutionary picture. Could you give us a quick refresher on black holes generally, the different types?
Sure. So a black hole is a region where mass is squeezed into such a tiny volume that gravity becomes overwhelming. Nothing, not even light, can escape once it crosses the boundary called the event horizon. They're invisible directly.
On from collapsed stars, mostly.
The smaller ones, yes. Stellar mass black holes range from a few times the mass of our sun up to maybe 100 times. They can grow by pulling in material or merging.
Then the intermediate ones we just discussed.
Right, IMBHs. Roughly 100 up to maybe hundreds of thousands of solar masses, the missing link category.
And the biggest.
Supermassive black holes, or SMBHs. These are the monsters at galactic centers, ranging from hundreds of thousands to billions of times the sun's mass. They likely grow by swallowing huge amounts of gas in stars and by merging when galaxies collide. Studying all types helps us test fundamental physics, like Einstein's general relativity, in extreme environments.
Incredible cosmic objects. Great that Indian astronomy is contributing significantly here. Now, let's bring it back to Earth again, focusing on conservation. India's role in protecting big cats. What's the latest?
There's been a key development with the International Big Cat Alliance, or IBCA. India has signed the headquarters agreement with the IBCA.
Headquarters agreement. What does that mean practically?
It means India officially provides the legal framework for the IBCA headquarters and its secretariat to be based in India and operate effectively. It covers things like visas for staff, privileges, immunities for the organization and its people, the necessary legal groundwork for an international body.
So India's hosting the alliance. Is there financial support involved too?
Yes, a significant commitment. India has pledged 150 crore over 5 years, running from 2023-24 up to 2028-29. This money is intended to build up a core fund, develop infrastructure for the HQ, and cover the alliance's running costs during this initial period.
150 crore, that's substantial. Remind us about the IBCA itself. When was it launched and what's its main goal?
India launched the IBCA initiative back in 2023. It was time to mark 50 years of Project Tiger, India's own flagship conservation program. It became a formal treaty-based intergovernmental organization more recently in January 2025 when its framework agreement came into force.
And who are the members so far?
Currently, 5 countries have formally joined by ratifying the agreement: Nicaragua, Eswatini, India itself, Somalia, and Liberia. More are expected to join.
And the big cats it covers, which species?
It aims to conserve the 7 major big cats globally: tiger, lion, leopard, snow leopard, cheetah, jaguar, and puma.
And India is home to?
5 of those 7. Tiger, lion, leopard, snow leopard, and the recently reintroduced cheetah. So India has a huge stake and a lot of experience in this area.
Makes sense for India to lead this initiative. Are there other major efforts, national or global, we should mention?
Definitely. Globally, the St. Petersburg Declaration on Tiger Conservation from 2010 was key. It set the TX2 goal, aiming to double wild tiger numbers by 2022.
Did we achieve that?
Globally, not quite, but several countries, including India, saw significant increases. Nationally, besides Project Tiger since '73, India also launched Project Lion in 2020, specifically for the conservation of the Asiatic lions in Gur. So there's a strong history and ongoing commitment.
A strong focus on conservation leadership. Okay, let's move into our final segment, the rapid-fire round of updates. Lots to cover here briefly. First up, secure communications.
Yes, a successful test of India's first quantum key distribution, or QKD, system running over multi-core fiber, MCF. This was a collaboration between CDOT and Sterlite Technologies.
Okay, break that down. Multi-core fiber, what's the advantage?
MCF basically packs multiple optical fiber cores into a single strand of fiber. It dramatically increases the data capacity without needing more physical cables, saves space, saves cost in laying down infrastructure. Think more data lanes on the same highway.
Got it. And quantum key distribution, QKD, that's about security.
Exactly. QKD uses principles of quantum mechanics to share encryption keys between 2 parties in a way that is theoretically unhackable.
How does it achieve that security?
It sends photons, single particles of light prepared in specific random quantum states. The laws of quantum physics say that if anyone tries to intercept or measure these photons to steal the key, the very act of measuring will disturb their quantum states. This disturbance alerts the legitimate users that someone is eavesdropping.
So any attempt to listen in is immediately detectable.
That's the core security promise. You can't copy quantum information without changing it.
Powerful. But are there practical hurdles? Limitations?
Yes, QKD isn't a magic bullet yet. It requires specialized, often expensive equipment. It can be vulnerable to denial of service attacks blocking the signal. Integrating it with existing networks is complex, and the distance over which it works reliably is still limited, though improving.
Okay. Cutting-edge tech with challenges. Next update. Organ transplants.
NATO, the National Organ and Tissue Transplant Organization, is pushing for wider implementation of swap organ transplants.
Swap transplants, how does that work?
It's for situations where a patient has a willing donor, maybe a relative, but they are incompatible, wrong blood type, tissue mismatch. A swap finds another incompatible donor-recipient pair, and they essentially exchange donors. So donor A gives to recipient B, and donor B gives to recipient A. Both patients get a compatible organ they wouldn't otherwise receive.
A clever way to increase transplant numbers from willing donors. And NATO oversees this.
Yes, NATO is the national apex body under the Health Ministry. It implements the HOT Act, the law governing organ transplants. It manages the national network, storage, registries, and works with state-level bodies, ROTIOs and SOTOs. It's based at Safdarjung Hospital in Delhi.
Good to know. Moving to economics, the Index of Industrial Production, IIP.
Yes, a change in how it's released, starting from April 2025 data. It will now come out much faster on the 28th of the following month, so within 28 days.
That's a quicker snapshot of industrial health.
Right. And they're simplifying it to just 2 estimates. A quick estimate and then a final estimate instead of 3 releases previously.
And the IIP itself, quick reminder.
It's a key indicator measuring the volume change in industrial production month on month. Base year is 2011-12. Compiled by the CSO Central Statistics Office. Covers mining, manufacturing, and electricity sectors.
Okay, noted. On a different note, remembering a key figure.
Yes. April 17th was the death anniversary of Dr. Sarvepalli Radhakrishnan, India's second president, but also a renowned philosopher and educator.
Teacher's Day is his birthday, September 5th.
Exactly. He deeply believed in education's power. He held prestigious academic posts, was ambassador to the Soviet Union, then vice president, then president from 62 to 67, a prolific writer, and a Bharat Ratna recipient in 1954. A truly influential figure.
Indeed. Shifting to environmental geography, the Aral Sea.
Recent studies show geological changes, specifically changes in elevation in the dried-up basin of the Aral Sea.
The sea that famously vanished.
Pretty much. It was once a huge saltwater lake between Kazakhstan and Uzbekistan, fed by the Amudarya and Sirdarya rivers. River diversions for Soviet irrigation projects caused it to shrink drastically, leaving behind the Uralkim Desert a source of dust storms and ecological problems. These new studies are tracking how the exposed land itself is changing.
A stark environmental lesson. Next, financial regulation.
An MOU Memorandum of Understanding has been signed between the Financial Intelligence Unit India, FIU-IND, and the Reserve Bank of India, RBI.
For what purpose?
To improve coordination in implementing the Prevention of Money Laundering Act, PMLA. Basically, sharing information and working together more effectively against money laundering and terrorism financing. FIU-IND is the central agency for handling suspicious financial transaction reports. It reports to the Economic Intelligence Council.
Better coordination against financial crime. Good. What about pollution control in power plants?
There is a study recommending a rethink of the 2015 policy that mandated flue gas desulfurization, FGD, systems for all coal power plants.
FGD, that's to remove sulfur dioxide, SO2.
Yeah. Correct. SO2 contributes to air pollution and acid rain. FGD uses alkaline substances like limestone slurry to scrub the SO2 out of exhaust gases.
So what's the suggested change?
The study suggests maybe rolling back the universal mandate and instead focusing FGD installation primarily on plants that use imported coal, which can be higher in sulfur, or domestic coal with sulfur content above a certain threshold, say 0.5%. It's a debate about cost-effectiveness versus universal environmental control.
An important policy discussion. Next, electric vehicles and the grid.
Kerala State Electricity Board, KSEB, and IIT Bombay are piloting vehicle-to-grid, or V2G, technology.
V2G sounds futuristic. What is it?
It allows electric vehicle batteries not just to take power from the grid, but also to send power back to the grid when needed.
So the car battery helps power the grid?
Potentially, yes. When EVs are parked and plugged in, they could act like a huge network of distributed batteries. This could help stabilize the grid, especially with fluctuating renewable energy sources like solar and wind. It could smooth out demand peaks and maybe even let EV owners earn money by selling power back.
Turning cars into grid assets. Very interesting concept. Another Kerala initiative.
Yes, Kerala has become the first state to launch online permanent look-at-alat services.
Look into what's going online.
Permanent look-at-alats specifically. These are established under the Legal Services Authorities Act for resolving disputes concerning public utility services, things like transport, communication, power, water supply. They have the powers of a civil court.
And the online aspect.
Makes access easier. These look-at-alats are a compulsory first step before litigation for these services, handling cases up to 1 crore. Their decisions are final and binding. Going online streamlines the process.
Improving access to justice through tech. Finally, heritage news.
South Africa's Cradle of Humankind caves have reopened. They were closed for 3 years due to flooding.
The Cradle of Humankind. UNESCO site, right? Famous for fossils.
Exactly. Near Johannesburg. It's incredibly rich in fossils documenting human evolution over the last 3.5 million years or so. Sites like Sterkfontein, Swartkrans, where major finds like Australopithecus africanus were made. It's great news for paleontological research and tourism that they're accessible again.
Fantastic.
Yeah.
A real window into our deep past. Well, that wraps up our rapid-fire round.
Quite a range of updates covered there.
It certainly was. And that brings us to the end of this deep dive for April 19th, 2025, Part 2. We really hope this session has been valuable for you, our fellow UPSC aspirants, offering clarity on these current affairs, whether new topics or helpful revisions.
Yes, try to think about the linkages. How does fundamental physics research connect to technological applications? How does space exploration potentially inform environmental challenges on Earth? How do international agreements impact national conservation efforts? Seeing these connections is key for mains answers and essays.
Absolutely. Consider the implications. The ethics of searching for alien life, the economics of environmental regulations, the role of technology in governance. Plenty to think about.
And perhaps a final thought to mull over.
Go ahead.
Given the twin prospects, the exciting possibility of finding life elsewhere, and the urgent need to sustain life here, where should humanity's priorities lie in science and policy over the next few decades? What's the most crucial focus?
A big question indeed, something to ponder. If you found this discussion helpful for your UPSC journey, please do give us a like and subscribe to the Deep Dive for more analyses like this.
Thanks for tuning in.
Thank you for joining us today.